Okay guys, here we are today. Our lesson for today, guys, is equations and inequalities with rational numbers. Just a little bigger for us. Alright, so basically we're going back to our equations, 1- and 2-step, multi-step equations. We're now just bringing in rational numbers, which basically means we're going to have fractions in there. Because remember, a rational number is any number that can be written as a fraction, or which stands for the quotient of two numbers. Okay, so what we are going to do with these first ones is just work on solving these equations. First one we're going to do, example 1, is with the multiplicative inverse. So right here I am, multiplying 4/7 times x to equal 12. Now one way to do this is, since I'm multiplying, is to divide both sides by 4/7. But since we just got done dividing fractions and learned that dividing a fraction is the same as multiplying by the reciprocal, we're going to go straight to that multiplicative inverse, which is multiplying by the reciprocal, and bypass the whole division work. So if I have my problem like this, I would have 4/7 x equals negative 12. So my work for this would be to multiply both sides by the reciprocal. So multiply this side by 7/4, and multiply this side by 7/4. Now, looking at the left side of my equation, guys, anytime you multiply a number by its reciprocal, it equals 1. And when we multiply to solve equations, our goal is to get the variable, or the coefficient, the number in front of the variable, to 1. So when I do that, I can cross-cancel. 4 divided by 4, they both become 1s, and 7 divided by 7s both become 1. 1 times 1 is 1, 1 times 1 is 1, 1/1 is 1, so I'm left with x. Okay, that's all that equals 1. On this side, I can do negative 12/1, and then I can cross-cancel. 12 is on top, so that's going to become a 3, and the 4 is going to become a 1. That's a negative 3 times 7 is negative 21. That is over 1, so we don't write the over 1 part, that's what it is. So we get x equals negative 21. So to solve this equation with fractions, you just multiply by the reciprocal, which is the multiplicative inverse technique. Okay. Yes, you could divide both sides by 4/7, and then you'd eventually get to the same answer I did. Okay, I'm going to go on to my next problem, B. Okay, and B here, still working with the multiplicative inverse. This time we have a two-step equation. So the first thing I have to do before I can use my multiplicative inverse is I have to get rid of the 4/5 that's on the same side as the variable. So I'm going to subtract 4/5 from this side, and I'm going to subtract 4/5 from this side. This is going to give me negative 11/15 x equals, well, this work here, guys, I'm going to do off to the side. I don't want you to do within the problem. I want you to do it off to the side. So I'm going to do 1/3 minus 4/5. Remember, when we subtract, we got to find a common denominator, which is 15. So this becomes 5/15 minus this becomes 12/15. And when you subtract it, you get negative 7/15. 5 minus 12 is negative 7. So that's going to be negative 7/15. So then I put the result in there. Next thing I'm going to do now, as I have like I had in the last problem, is my multiplicative inverse step. So I'm going to multiply both sides by negative 15/11. It stays negative, remember, because a negative times a negative is a positive. These 11s cross off and become 1s, because 11 divided by 11 is 1. 15 divided by 15 is 1, same there. So that all that ends up to be a negative times a negative is a positive. 1 times 1 is 1, so I have 1 equals, on this side, I do negative 15/11. I can cross-cancel here. 15 divided by 15 is 1, so they both become 1. A negative times a negative is a positive. 7 times 1 is 7. 1 times 11 is 11. So you get x equals 7/11. And that is my final answer. Okay? So this first example here is using the multiplicative inverse. Now, I'm going to go on to my next slide. I am going to say before I do that, I'm going to go show you another way of solving a similar type problem. It's going to be different numbers, but a similar way of solving a problem like this. Okay? I'm going to go to my next example. When I get to my next example, you can see that it's basically the same type of problem that I just had. I got a two-step equation with fractions. This time I'm going to use a different technique. Instead of using the multiplicative inverse, I'm going to use a technique that we call clearing the fractions. This is a great technique to get rid of all of our fraction work so that we just have whole numbers. That is my goal when I clear. I can do this also with decimals. I'm going to show you an example with decimals next. Okay, so we can work with that, and we'll go. So what I'm going to do when I clear the fractions is I am going to look for a common denominator. And my common denominator on this one, between 16, 8, and 4, I have three numbers. My common denominator is 16. So I am going to multiply each fraction by 16, or 16 over 1. Sorry about the graphics there. If I multiply each fraction by 16 over 1, then I will end up with just whole numbers. So let me rewrite it. I'm going to space them out. So 7x minus 3/8. We'll give a little gap there, equals 3/4. Now I can multiply each by 16. I'm going to go ahead and change my pen color so you can see where I'm multiplying. So I'm going to multiply each of them by 16. I'm going to multiply this by 16. That's I left myself a little gap there. I'm going to multiply this by 16. Now, they're all going to be over 1 for my fraction's sake. Now when I cross cancel, the 16s become 1s, so I'm left with 7x. Minus, this 16 becomes 2, that 8 becomes a 1, that's 6, and the bottom is 1. Minus 6 equals, this 16 becomes 4, and that 4 becomes 1, 12. Okay, I'm just going to rewrite my answer up here. 7x minus 6 equals 12. That is the same thing that I just had there. I find a common denominator, and I multiply by that. Now I don't have to work with my fractions anymore. I can just go to my two-step equation. Add 6 to both sides, that gets that to 0, which leaves me with 7x equals 18. Divide both sides by 7, I get x equals 18/7, which I can turn into 2 and 4/7. That's my final answer. Okay, you could certainly do it the way I taught you before, or you can do it this way. Okay, in your target practice, I'll have you practice both, but by the time quizzes and tests come, you can use either method. So practice one, find the one that you like. They're for the similar type problems, but you might like this clearing fractions better. It ultimately deals with less fraction work in the end. Okay? All right, I'm going to go to my next example. If you need to pause this, go ahead and pause it. In my next example, I'm going to show you how it works with decimals. Okay? So when I look at these decimals, what I'm going to do is I'm going to look at my numbers after the decimal point, and I'm going to find the one that's the furthest. So that is my 14 there, 1, 4, 5 and 14 hundredths. So that's what I'm going to multiply by. So in this example, I'm going to multiply each number. Okay, and here's the deal I did not emphasize on the last one. You have to multiply each term by the same thing. So I'm going to scan up to my last problem real quick. Here I multiplied each term, 7/16 x, 3/8, and 3/4. Every term has to be multiplied by whatever number you're multiplying by. Okay, because you're not getting rid of anything. So if you only multiply it by on one side, you have to do each term on that side. Okay? So here I'm going to do that. I have to multiply each term by that. Now I can do the math. 2.3 times 100 is 230 equals, this is 514, plus this ends up to be, move the decimal point over 2, 80m. Now I can solve this. It's a little easier to solve. Subtract 514 from both sides. You get negative 284 equals 80m. Divide both sides by 80. Since this started as a decimal, it's going to end as a decimal. Negative 3 and 55 hundredths equals m. And there's your answer. So you can clear, that's a great way to get rid of decimals. With calculators, it's not a big of a deal, but really for those fractions, it's a great way to get rid of those. The key is you have to multiply each term by that amount. When we solve an equation, that's why we have to get rid of our adding or subtracting step first. Otherwise, if we did that earlier, we would have to get rid of each term then. Okay, I'm going to go to my last page. Okay, in example 3, we're going to solve an inequality. When solving an inequality here, I have a multi-step equation. So the first thing I need to do when I solve equations before I do anything is get rid of the two variables there. I have to combine like terms first if that's possible, and this is. Remember there's a 1 in front of that x, so it's going to be 1 minus 1/3. Okay, if you can't do that, that's going to be 3/3. Minus 1/3 is 2/3. Okay, so that's going to be 2/3 x minus 5 is less than 20. Now I could multiply everything by 3 to get rid of my fraction, but I'm not going to here because that's the only fraction. I can use my multiplicative inverse there fairly simply. So I'm just going to keep them as they are. So sometimes you want to make a decision like that. And I'm going to add 5 to both sides. If you did get rid of it by multiplying by 3, you have to multiply everything by 3. That would give me 2/3 x, that's 0, is less than 25. Now I'm going to use my multiplicative inverse steps. I'm going to multiply both sides by 3/2. Okay, those are going to cross out and become 1s. So I'm left with x is less than, there's no negative. Remember, if you divide or multiply both sides by negative, it switches it. I'm left with x equals, and this cannot cross cancel, so it's going to be 75 halves, which is going to turn into x is less than 37 1/2. And that is my final answer. Okay? Again, if problems start in fractions, they need to end in fractions. If problems start as decimals, they need to end in decimals. The only situation would be if it's a word problem or something. If it starts as a fraction, but then it's money, then you always want to write that and express that in money terms. So there are occasions that you would want to switch that up. Okay, that is our examples for today. Have a great night, and we'll see you tomorrow.